So we have seen the basic Objective-C concepts, from properties to syntax to protocols, and we have seen some memory management golden rules. Now we are in ready position to start developing our first iOS app. I know you guys are excited, right? So we'll first create a small workspace and we'll put everything in that workspace. Okay, so on your desktop you just create a folder of your name. So I'll be creating a folder of my name, so I say Priyank and I click on it. Inside this folder I'll be creating two subfolders. I say new folder, given. So this folder will contain all the sample code, images, material, whatever we share to you will be a part of this folder, and there will be another folder called session progress. Okay, now this folder is purely your folder. Okay, you will be creating all your assignments and all your application under this folder throughout a series of our tutorials. Okay, so this iOS level 1 folder will be a part of your course content, so we'll be just dragging it inside this. Now the samples contains a lot of icons which we need. Okay, so it contains icon, then there are some empty folders. We'll discuss about this when we come to that level. So all folder structures have been given to you, some parts, some sample images and resources now. So we'll be seeing this why these empty folders have been created when we come to that level of tutorial. Now let's start with our first exercise. Now first thing, on any platform when you start learning any new thing, we'll see the life cycle of the application. Okay, so I want to say create a new folder saying one dot life cycle. Please make sure you sequence your exercise properly, because the way the exercises are getting executed gives you a better learning curve. So please make sure you always have the serial number associated with all the exercise which we do. Now this is the workspace created. Now you have to open the Xcode. So when you open the Xcode, you're gonna get the welcome Xcode screen. There you can say create new project. Now Xcode is an IDE used for developing the apps for the iOS as well as the OS X, then simple term OS 10 and above. Now there are a lot of templates. We're going to start with the single view application template, because as we are aware of, iOS is purely a front end. It needs to have a UI, it needs to have a view in order to be an application. So we're going to start with the scratch level application. We're going to single view application, and when you say select the template, it gives you a form where it says give me a product name, organization name and everything. So I will say project 1. So this is my project. You can give your organization name, your personal name, and then in company identifier you just say com dot and put your organization name in a small case. It's like a package name, com dot. Okay, do not put any spaces. You can use uppercase letters, but it's always preferred to use small cases. Bundle identifier, if you see, it's a grayed out thing. You cannot modify it right here. It's something called a company identifier dot the product name. Now the significance of this we'll see when we're going to deploy the project. Class prefix is blank. If you put any text, it will act as a prefix for all the classes which you create in the project. We'll say blank, and we'll start our journey right from the iPhone launch. We'll see how people adapt the application whenever a new device was launched. Okay, so we want to understand that part of the theory properly, so that if tomorrow a new iOS set of devices come, like a television or something, you should be able to deploy your existing app on that new set of machines very fast. Okay, so in order to get that type of exposure, we will start from iPhone. Okay, and then we'll say next, the browser opens, you go to your folder, go and select your lifecycle folder and say create. Once the project gets created, we'll see the Xcode. Now if you see, there are three boxes lying on the right top toolbar. Now these are basically a view boxes. So if you see, the entire Xcode is divided into three parts: the left window, the right window, the bottom window, and the editor window. Now this is called navigation window, where it's subdivided into 8 more tabs. The first tab gives you a list of files, the second gives you threads, and so on. So mostly we're going to use this tab. The right hand side tab is used for showing the which file, the location of the file, the quick help, and it has some codes in that which we use with the other tools. So this is called help window. The bottom window is divided into 2 parts. The left hand part is called a debugger window, and the right hand side part is a console. And of course, the center one is called editor. Now if you're using 13-inch MacBook Pro or something like that, we avoid the right hand side window, and also we close the bottom. So my editor screen becomes bigger enough. Now if you see, there are 2 classes gets created. One is AppDelegate and other one is view controller. As we are aware of, in Objective-C, every class are physically divided into 2 files, the .h and the .m. So the template have created 2 classes for me. One is called AppDelegate and another one is view controller. Now we are absolutely not aware what these classes are of, right? Now let's explore the folder and you'll see something called main. Now when you see a main file, you are aware of main function, right? Every software starts with main function. Now here you'll see some set of code which we are not familiar with. Now what is auto release spool? We'll see when we go further in a course. And there's one single function which takes 4 arguments. The first 2 arguments are pretty simple. They are the command line argument. The third argument is nil. When you pass nil, it will create the object of your application. Now every app which you see on the iOS device is nothing but the object of your application. So normally we pass nil, and the 4th parameter is basically the listener to the application layer. So how will an iOS gonna communicate with your application? Who will be the one which you gonna listen to the callback generated by the iOS for your application? And that parameter is the 4th parameter. Now in this case we have to pass the references in string. So Objective-C has a special function called NSLog from class, where you pass the class reference and it will convert into string. So basically AppDelegate is nothing but a listener class at the application layer. So all the iOS callback which are associated with your iOS app will be handled by this class. So from this we come to know that the control will go to the AppDelegate level. So let's see what is the AppDelegate. So I'll first investigate what is an AppDelegate.h, and then we'll move to the AppDelegate.m. Now as we have discussed, it's entirely a front-end application development. So any class you create for the iOS application development, the first thing we import will be UI kit, user interface kit. Okay. Now the header file starts with the @interface followed by the name of the class colon the superclass. Now we have discussed that a class is a valid Objective-C class if its root class is NS object. Let's try to prove it. So I select this class, I say right click, jump to definition, and when I go to jump to definition, I see UI responder extends NS object. So practically it's a valid hierarchy. It confirms a protocol called UIApplicationDelegate. Let's check it out So if you see, it's protocol UI application delegate, where first half of the word is basically the physical file where it's located, followed by the word delegate. So whenever you create your own protocols, or whenever you see a word called delegate, you have to understand there are some callbacks which you have to implement. In terms of Java, we call them as interface. So Java concept of interface it's completely same as protocol concept in iOS, or I would say in Objective-C. Now if you see, all methods which are declared under the protocol are all optional. So that's a massive difference between the interface of Java and the protocols in Objective-C. Protocols can have an optional method which allows the more flexibility. If a class which implements optional method, then only the control will go there, and if it's not implementing, the control won't go there. Whereas in case of interface in Java, you have to implement all the methods. So if you see, these are all sort of methods. These are called callbacks from the OS. Now as you see, there is no required method, so UIApplicationDelegate is considered to be informal protocol. If there is at least one required method, we call it as a formal protocol. So from here, I understand AppDelegate extends the UI responder and confirms the UI application delegate. Now there's a property declared called window of type UI window. Now I'm not aware of what it is UI window all about. So let's go to .m. In .m, you'll find there are few functions, or I would say few methods implemented. Now whenever I see a new code, I do not start reading the code because I'm not aware of the code. So what we basically do is we write logs and run your application. We run the application as a normal user, and we'll see the logs of the function name in the console. So as you run the app, we get the sequence of functions which are getting executed, and that gives me a more confident in understanding the software whose code I am reading. So we're going to perform the same exercise to check how these methods are getting called. These all methods are optional method declared in the UI application delegate. So we'll just write NSLog as a first line of code in all of the method. So I say NSLog. Now we use NSLog to generate the console output. So normally I use the function name as the logs so that I don't have to come back to the code and map the logs with the function name. So best practice, I would always say, in order to understand the functional flow of the application, always write logs as function name. So I wrote NSLog. I'll say command C, command V. I double click on this word, I say command C, command V. Similarly, I'll just repeat the same exercise for all the remaining methods. And I will copy the respective name inside the NSLog. Done. So I've done. And then there is a play button, I would say run button. I'll click on it and let's see. I get a white screen and I get some couple of logs. If you see, the first method which gets called from as a callback is application did finish launching with option, and then we get application did become active. Now as we are aware of, there's only one hardware button which we say a home button on the iOS, which makes your app shut down, or you could say goes in a background. Now if you see, the simulator doesn't have that hardware button. There is a shortcut key called Command Shift H. When you press this, it acts as a home key. Command Shift H. Now when you click this, you'll see your app gives you a callback saying application will resign active, and application did enter background. Now with the iOS 4 and above, multitasking was introduced. The application goes in the background when you press the home button. Prior to iOS 4, when you used to press the home button, application was terminated. Now you can relaunch your app. Now to relaunch your app, you double click on your home button. So in order to simulate that, you say Command Shift and double tap your Edge button. So when you double tap, you will see your application running in the background. You just click on it, it will come back in your main screen, and you will see there are some logs getting printed. Application will enter foreground, application did become active. Now this is a normal life cycle. Suppose you want to terminate the app, you want to say Command Shift H, home button, you want to press and open the multitask panel, and then you want to swap it to terminate the app. Now when you swap this, you get LLDB, means your compiler crashed. Now this is okay, do not have to worry about it because it's simulator. Xcode was running the simulator. If you wanted to stop the app, then you would have instructed the Xcode to terminate. It's fine. So with this exercise, what we have seen is a typical life cycle of the iOS application. So when an application is launched first time, we get application did begin launching with option as a callback, and immediately we get application become active. When a user presses home button, the first method which get executed is will resign active and then did enter background. Then when a user launches the app from the background, it's called will enter foreground, and then we'll call did become active. So this is a pretty typical life cycle of the iPhone application. Now there is a lot of method which gets triggered by the OS depending upon the application state. So you have many methods to implement, but this is a typical life cycle which every iOS application goes through it. Therefore the template implements this set of methods. But if your app is listening to the Apple push notification servers or gets triggered by the local notification or the Bluetooth transfer, respective methods have been declared, and you can implement those methods in your AppDelegate.m. So everyone, I hope everyone are clear with the typical life cycle of the Apple iOS application, and everyone is now familiar with the class AppDelegate. So AppDelegate, you can assume, or you should say, it's a global class for your application. This class, or say object of AppDelegate, is responsible for listening to all the callbacks generated by the iOS for your application. So this exercise is over. You can close your Xcode project, and obviously the simulator